Good day guys, we're looking at another second order differential equation. Again, we're looking at the particular solution, that's why you see those conditions given. So it always starts with a general, that's the general format of the general, where we will need to get our YC. Our YC is our complementary function, YP is the particular integral. So YC, we always use the left side to create a quadratic expression. So to create that expression, the second derivative, we'll call it r squared. The first derivative, we'll call it r. Y will be 1. And I keep reminding you that if y is 1, then you know it's 8 times 1 and not 8 1. And because we don't use the right hand side for our complementary function, we always replace whatever is on the right part as 0, so that at the end of this step you must see yourself with a quadratic equation, which you can solve with any method you want. So looking at this quadratic, I see 2 is common. To make life easy for me, I can divide all through by 2. So if I divide by 2, this is what it gives me. So again, it looks like a quadratic that I can solve by factorization. So when I look at it, it is like r plus 2 multiplying r plus 2. You can also use the formula to solve, to be on the safe side. And that shows to me that r1 is equal to negative 2. And r2 is also equal to negative 2. So in short, r1 is equal to r2. So we can now go to page 7 of our formula sheet if you are an N6 student to see a formula, to see how to write your YC. You simply target there the formula where r1 and r2 are the same. And what you will be seeing will be e to the power. We'll make it a formula sheet. It's e to the power r. Our r is negative 2x in bracket a plus bx. So that's now your YC. So with YC, we are now done. So YC, I always expect every N6 student to be able to get that right, because it's all about creating a quadratic from your original differential equation. Then if you can solve your quadratic, you go to page 7, you copy down your formula, replacing this r by your negative 2. So now let's go to YP. YP will always depend on the choice of the function on the right hand side. You can see that on the right, our function is a quadratic. That means your YP must be a quadratic. And you'll see the way I'll choose my YP. My YP is chosen like this, because a standard quadratic must take 3 terms. It doesn't matter how many terms are here. What makes this right hand side a quadratic is the fact that we've got x squared. It's not about the number of terms. So your YP must be chosen to get 3 terms, because that's a standard quadratic. So I will differentiate it 2 times. So if I do for the first time, I will get 2c plus d. Then if I differentiate it for the second time, I will get 2c. So that's the standard procedure. Then to calculate the values of c, d, and e, I will transfer this information into the original differential equation, where the second derivative we will replace it by 2c, which is equal to yp. The first derivative we will replace by 2c plus d. Is it 2cx? Sorry for this. This one is supposed to be 2cx from the derivative plus d. Then your y we will replace by your yp. Then will be equal to 2x. So we'll do that this side to calculate those values. So I'll get 2 into y, the second derivative, which is 2c plus 8 into the first derivative there. We will replace by the first derivative of yp, which is 2cx plus d plus 8 times y. Our y will be replaced by our yc, by our yp. And we equate this to the quadratic on the right, which is 2x squared, just to make sure I write it 3 terms as the standard quadratic. That's how I complete it. Then I can start comparing coefficients. So I look for coefficient of x squared, coefficient of x squared. On the left, you see that we've got 8c, on the right, it's a 2. So we get 8c is equal to 2. That implies that c is equal to 2 over 8 or 1 over 4. If I divide both sides by 8, then I'll go to coefficient equal to 0. You see on the right there is no x. But we know what is c, so if we multiply this by 1 over 4, 16 times 1 over 4 is by 16 divided by 4, which is 4 plus 8d is equal to 0. And if you were to solve this, you will see that d should be equal to negative 4 over 8 or negative a half, because 8 d will pass that equal to the right, which is by negative 8. So that is your d. Then you can now go to the constant term on the left. Let's see 4c first, followed by 8d, then 8e, on the right there is a 0. So we get back here, c is 1 over 4 times 4 is 1, d is negative 1 over 2 times 8, so it's like 8 divided by negative 2, which is negative 4, plus 8e is equal to 0. So if this 2 becomes negative 3, that side it's a 3, so we are having 8e is equal to 3, and this will be telling us that e is equal to 3 over 8. So now that we know the c, d, and e, it means we now know our yp. Our c is 1 over 4 x squared. Our d is negative a half x. Our e is 3 over 8. And this can also show to us that we can now write our general solution, which is yc plus yp. And that means we've got yc as e to the power negative 2x in bracket a plus bx plus 1 over 4x squared minus 1 over 2x plus 3 over 8. So this is our general solution. So that's what we call our general solution. So we can now start the journey of the particular solution, which means we need to calculate capital A and capital B using the conditions given in the problem. So the first condition says 1 is equal to 2 when x is equal to 0. So we are substituting this into the general solution. So y is 2, I'm putting it there. When x is 0, it means e to the power 0 is 1. So it's like, let's just put it first, e to the power 0 into a plus 0, because x is 0. Then 2 0, then 2 0, then again 3 over 8. So this shows to us that 3 over 8 is a frame of 2. So if we cross this over, we're getting 2 minus 3 over 8. That gives us 13 over 8. So we'll see that 13 on 8 is equal to a, because e to the power 0 is 1. 1 plus 0, the a plus 0 is a, so we are now having a. Now go to the next condition, which says dy dx is equal to 3 when x is 0. Again, dy dx, we don't know it. If you need dy dx, you must get it from your general solution. So to do that, you need to differentiate. And don't forget, the general solution this time is a product of an exponential function and a linear function. So to differentiate, you need the product rule where you get u and v, and to differentiate that, you will be using the u v prime plus v u prime. Don't forget that is how you differentiate a product. So if I differentiate there, my u is e to the power negative 2x. V prime means I differentiate what is in bracket, which if I differentiate, I will get b plus now v u prime. U prime means I differentiate e, will give me negative 2e to the power negative 2. Then I multiply by v, which is what is in bracket. Then cross over to yp. If you differentiate, you will get 1 over 2x minus 1 over 2, because of the derivative of this will give us 2 over 4x minus a half, and that is a 0. Then now I can replace. So if I'm replacing, the first derivative is 3, e to the power 0, or this is, so it's a 1, so the first term here is b, e to the power 0 is 1 times negative 2, so we get negative 2a, because here will be 0, here will be 1, so I have negative 2 0, and there is negative a half. So a half crosses to make 3. 3 plus a half is 3 and a half, which is 7 over 2 is equal to b minus 2a. So, but we already know what is a to be 13 over 8. So if we bring down a, we get b minus 2 into 13 over 8. So 13 over 8 will now become a 26 over 8, which will add to 7 over 2. So it's 7 over 2 plus 26 on 8. That should give us b as 27 over 4. So this one is crossing there to add up to 7 over 2. So now we know our a and we know our b. We can now write down our particular solution by copying the general solution y equal to e to the power negative 2x. Bracket we make a, our a